All right, so on day 2, this is for Unit 1, we are going to talk a lot about segments today, right? Because if you think about it, segments are really one of the only things we can work with in geometry that doesn't have infinite length, right? Lines go on forever and ever and ever. Rays go on forever and ever and ever. So a segment actually has 2 endpoints. So that means we can measure it, we can work with it, we can make shapes with it, right? So most of the time we're working with segments in geometry. So we're going to talk a lot about segments today. Okay, so we're going to introduce a new vocabulary word today, right? We're going to use the word congruent, right? You've probably heard that word before. So 2 segments, again, don't forget segments. I'm just going to kind of draw a little picture of a segment above it, right? Have 2 endpoints, right? Here, I'll just kind of label it A, B, and remember notation-wise, we would refer to that as segment AB, right, for our notation. All right, so 2 segments are congruent if and only if they have the same length or measure, which is basically the same thing, right? If I measure something, I'm finding its length. Okay, so if 2 segments are the exact same length, we would call them congruent. The symbol for congruent is an equal sign with a little tilde above it. It's actually the similarity symbol for math, right? And so put an equal sign and a similarity symbol together and you have a congruent symbol. And anytime you see that, right, that means is congruent to, right? Because you're comparing 2 segments. Typically, we use this a lot when we have pictures, right, such as this triangle that we're looking at. We know in a picture, the picture always tries to tell us, it always gives us clues, right? And your job as a geometry student is to be a clue finder, right? And so obviously in this picture, these tick marks, let me highlight them, right? These little tick marks right here, because there's only one of them, because each one of those segments has 1 tick mark, that is telling us that those 2 segments are congruent to one another, right? So they're the exact same length. So notation-wise, I would write segment AB is congruent to, using our new symbol, segment AC. Okay, and so that's how we use our congruency symbol. Now, if there's more than 1 pair of congruent segments in your picture, then we use more hash marks or tick marks, right? So as you can see in this red and blue triangle down here, right, we have a single tick mark on AB and a single tick mark on ED. So we know those 2 segments are congruent to one another, right? And then I see a double tick mark. That means he is congruent to the double tick mark over here. Right, so if you want, you can write out a bunch of statements just to practice, right? I know AB on my red triangle is congruent to segment DE on my blue triangle, right? And again, I know this because I'm just simply matching up the number of tick marks, okay? I know AC is congruent to DF. And because of the triple tick marks, I know that segment BC on the red triangle is congruent to segment EF on the blue triangle. So we can write all 3 of these congruency statements because of those clues, right, that picture is trying to tell me. Okay, so we want to look for those for sure. We're not talking about angles yet. We'll talk about those in a few days. But just to let you know, angles can be congruent too, right? And so we kind of do the same thing with angles, except instead of tick marks, we use arcs, right? So you can see, hopefully, let me circle, like right here, angle B has a single arc inside of it. So if I go find the angle E over here that also has a single arc, that tells me that those 2 angles are congruent to each other. And we would say angle B, again, I know we haven't talked about angles yet, but I'm just, putting this in your head for now. Angle B is congruent to angle E. Right, so we can still use that congruency symbol with angles as well. Again, we'll talk a lot more about angles here in just a couple of days. And clearly, angle A is congruent to angle D because they have double arcs, right? And then we have C and F with triple arcs, and so that picture is trying to clue us in that those 2 angles are congruent in measure, okay? All right, now we need to talk about the difference between congruent and equal, okay? So this one can be kind of tricky. So what I want us to do is I'm going to take a ruler and I'm going to measure the length of segment XY, which I can do because they're finite, right? They don't go on forever and ever and ever like lines and rays do. Okay, so I'm going to take my ruler and I'm going to measure how long that segment is roughly. It doesn't have to be exact. So, and I am measuring on an iPad screen, so obviously that's subjective to my screen. So I'm going to write that XY is equal to, let me see, I'm going to say about 7.2 centimeters. Right, on my screen. Obviously, if you're on paper, it'd be different, or a bigger screen, it would be different, but that's not really the point, right? The point is, this is how I would write the length of that statement, right? And do you notice anything missing? Okay. Did you happen to notice that I did not put a bar over the XY? Okay. And that is a difference in the notation for equals versus congruent. Okay, when you're talking about the segment as an object and you're comparing its length, like congruency wise, to another segment, then we're talking about the segment itself, so we use the bar. If we're talking about using the equal sign, we do not, I'm just going to write it in this bubble, we do not use the segment bar, which it doesn't really have a special name or anything. We do not use the segment bar with an equal sign. So anytime you are talking about the actual numerical length of a segment, because again, only segments have length, right? So there's really no reason for us to put the segment bar, because if you're telling me something is 8 centimeters long or 7 centimeters long or 2 miles long, I know it has to be a segment because lines and rays are not measurable, right? So we don't need that segment bar. Plus, it tells us that we're actually referring to the numerical length of something. So anytime you see XY hanging out all by itself without the segment bar, that means the length, hold on one second, the length of segment XY. Right? Anytime you see a question and you don't see a bar, it is referring to the actual numerical length of the segment. Right? XY with a bar over it just simply means segment XY, right? You're just referring to it as an object and you're not actually comparing its length to anything. Okay, I know that's kind of weird. You'll get used to it, I promise. We'll be going back and forth so we can practice that. Okay. All right, so our next big vocabulary word that we're going to focus on today is midpoint. Okay, so what do you think of when you hear the word midpoint? Okay, hopefully we're all thinking middle, right? So if I have a segment AB, there's definitely one point that lies perfectly in the middle, right? And we would call him the midpoint. So I'm just going to kind of eyeball it. Let's say that's here. Okay, so I'm going to label this M for midpoint. It could be any letter. It doesn't have to be an M. So in yellow highlighter right here is the formal definition that we're going to write down. So the formal definition of a midpoint is a point that bisects, which is technically another vocabulary word, a segment or divides the segment into two congruent segments. Because obviously if you have found the midpoint, then that means that this side has to be congruent to this side. So we could write the statement that AM has to be congruent to MB. And of course, I'm going to use segment bars because I'm using a congruency symbol. Here, let me, I'm going to put up here, I'm going to add a congruency. Here, I'm going to put an equal sign, right? No bar, equal sign, congruency symbol, use the bar, okay? So I can say that AM has to be congruent to MB because M is the midpoint, right? So it's bisecting or cutting in half, okay? All right, so now we have this number line, right? We're going to work with number lines for a little bit. We've got J, which appears to be located at 1 on the number line, and E, which appears to be at 7. So on a number line, we of course should be able to find the midpoint, right? We want the number that's between 1 and 7, right? So you can kind of work your way in if you want to use your fingers, like 1, 1, 2, 2, 3, 3, when we end up here, right? So you can just kind of work your way in, or you can just realize that our midpoint is 4. Right? That's the number directly in the middle, which makes sense because the distance from 1 to 4 is 3, and the distance from 4 to 7 is also 3. Right? So we've definitely found the number in the middle. So the coordinate is 4. I've already labeled it M. And so what are some things that we can conclude? Well, we know that JM, right, is congruent to ME. We could also say that JM equals 3, right? Because now we're actually referring to its length. We could say ME equals 3. We could say JE equals 6, right? The length of the whole segment itself. So notice the difference between the equal signs, right? We're actually talking about the numerical length versus the congruency symbol when we're comparing the length of two segments against one another, okay? We also want to make sure that we know how to find midpoints algebraically. We'll talk a lot more about this tomorrow. But sometimes we don't have number lines, or maybe we have really big numbers or negative numbers or decimal numbers. So we want to make sure that we can also put a math formula to it. So just in case we don't actually have a friendly number line for us, right? And so if you think about the word midpoint, right? The midpoint we know is the number in the middle. Well, what's another word for the number in the middle? The average, right? Well, how do we calculate the average, right? Well, if you take two tests and you want to know what your current test average is, what do? You add them up, you divide by 2, right? And that's exactly what we're going to do right here. We're going to calculate the average. So we have one endpoint of 1, the other endpoint is at 7, and then we're going to divide by 2. And you can see that that gives us 8 divided by 2, which gives us 4. Right, and so we've calculated the average, or the middle number, or the midpoint of the line segment. Okay, so we're going to use that a lot more tomorrow, but it's just a handy little thing to know. All right, on this little section, we're going to name each midpoint, and we're going to write a congruency statement. Okay, if there are any. All right, so here we go. Obviously, in this picture, right, R is the midpoint. I'm just going to kind of label that. And if I have a midpoint, then that automatically means I can write a congruency statement, right? Because I've clearly bisected a segment into two congruent halves, right? So because R is a midpoint, we can say that PR is congruent to RQ. Okay. The second picture, it looks a little bit more confusing, but remember, you don't have to look at the picture as a whole, right? We don't just have to have one midpoint. So hopefully you can see that if I just look at segment WY and completely ignore this part, well then X is acting as a midpoint for segment WY all by itself. So X is a midpoint, not of the entire segment WZ, of course, but only for WY. So I could, of course, then say that segment WX is congruent to segment XY, right? And of course, on the flip side of that, I could just look at XZ, completely ignore that left side, and then Y must be a midpoint because I can see those congruencies. And if Y is a midpoint, then that means segment XY is congruent to segment XZ. Okay. And then if we look at this picture, right, you can think about it for a second if you need to. Pause the video if you want. So this one's kind of tricky, right? I'm going to kind of focus on this part first, right? A lot of people want to say that D is a midpoint because it totally looks like it's in the middle of AC. However, There are no clues that would inform me of that. I would have to see congruency marks that prove to me that those segments are congruent, right? Remember, we're clue finders. You are not allowed to make assumptions about any of that, right? And so if I don't see the congruency marks, or I don't have any other information to go on, then I definitely cannot say that D is a midpoint, okay? The other thing that confuses people sometimes is like, oh, well, if I have 2 congruency marks, there must be a midpoint. Well, just because there's 2 congruency marks, for instance, does not make B a midpoint, right? Because it has to all be collinear, right? It has to be one solid line segment. So if BA was way out here, right, and my congruency mark was here, well then yes, B would be a midpoint, right? Because CBA is all collinear, making one solid segment, and you're cutting a segment in half. But this one is bending, right? We have a definite sharp angle here, and so there are no midpoints in this picture. Okay?